Section 2.8, this is combining functions, composite functions, so different operations on functions we're going to do in this section. Operations on functions are similar to operations on numbers. Each operation has a formal definition which produces a new function. Each function listed below is defined for all x in the domains of both f and g. So the sum of f and x, f plus g of x, you can write it as f of x plus g of x. F minus g of x, you can write as f of x minus g of x. And f times g of x can be written as f of x times g of x. Division, f divided by g of x, can be written as f of x divided by g of x, given that g of x is not equal to 0. Because if it were, it would be undefined. So let f of x be x plus 3 and g of x, x minus 2. The sum of f plus g of x is equal to f of x plus g of x. F of x is x plus 3. G of x is x minus 2. And now all you're doing is combining your like terms. X plus x is 2x. 3 minus 2 is 1. The difference, f minus g of x, can be written as f of x minus g of x. So you can write it as x plus 3 minus the quantity x minus 2. Be very careful. Distribute the negative, and now combine your like terms. The x's will cancel out because you have an x minus x. So you don't have any x's, but you have 3 plus 2, which is 5. Product, f times g of x, can be written as f of x times g of x. F of x is x plus 3. G of x is x minus 2. FOIL, and you'll get x squared plus 3x minus 2x. 3x minus 2x is x. 3 times negative 2 is 6. Quotient, f of x divided by g of x. F of x is x plus 3. G of x is x minus 2. You're not done here. You have to write x cannot equal 2. Because if it did equal 2, you'd have 0 in the denominator, which is undefined. So why don't you put it on pause, try these yourself, and then start the video and make sure you got them correct. F of x plus x, or f plus g of x is f of x plus g of x, x squared plus x plus 1. So you have x squared plus 2x plus 1. The difference, f minus g of x, is f of x minus g of x. So I have x squared plus x minus the quantity x plus 1. Don't forget to distribute the negative, and then you end up with x squared minus 1. F times g of x is f of x times g of x. First outer inner last, to multiply it, you end up with x cubed, x squared, and another x squared is 2x squared, and an x. X cubed, x squared, another x squared is 2x squared, plus x. Quotient. F of x is x squared plus x. The denominator, you have x plus 1. You're not done here. Let's simplify it. But before you simplify it, you know x cannot equal negative 1 because of that denominator. Factor the top. you can factor an x out. You can cancel the x plus 1s. So you have x, but you still have x cannot equal negative 1. Because if this were 0, 0 over 0 is undefined. So you can't have 0 over 0. Another way of combining functions is called the composite function. The composite function is noted f composite g, or f composite g. It's written either way. They're the same thing. X has to be in the domain of your g of x. So x has to be in this domain, and then g of x has to be in the domain of f of x. So let's find f of g of x and g of f of x for these two functions. So I have f of, instead of g of x is x squared. So I can just do a direct substitution here. I can write f of x squared. So all I did was did a direct substitution. And if I know that f of x is equal to x plus 2, f of something is equal to something plus 2, that something is x squared. So it's x squared plus 2. So that is f of g of x. So the function g of x squares any number. The function f of x adds 2 to any number. So I did g of x first, I squared a number, and then I did f of x, I added 2. The domain for this is all real numbers. Domain for the g of x is all real numbers. The domain for when I plug g of x into f of x, it's still all real numbers. Now let's do g of f of x. Instead of f of x, I'm going to do a substitution, x plus 2. So I'll have g of f of x is x plus 2, so I can put x plus 2 in the parentheses. G of x is x squared. So g of x is equal to x squared. Instead of x squared, I have x plus 2 squared. And you can leave it like that. You could FOIL it if you want. If you FOILed it, you get x squared plus 4x plus 4. So this time, I'm doing the f function first, which is adding 2. And then after I add 2, I'm doing the g function, which is squaring it. So I added 2 first, then I squared it. The domain here is still all real numbers. So notice I don't get the same thing necessarily with that. One is x squared plus 2, the other is x plus 2 quantity squared. Okay? So this composite function is not commutative. So order is important. Order is important. Find f of g of x and also g of f of x for these two functions. If you want, pause it now and then try it yourself and then start the video. So I have f of, instead of g of x, I have 2x. So I did a direct substitution. And now, into my f function, I have f of 2x instead of f of x. If f of x is 1 over x, f of 2x is 1 over 2x. So I have 1 over 2x. Can't have x in the, or 0 in the denominator, so x cannot equal 0. In interval notation, the domain would be from negative infinity to 0, union 0 to positive infinity. G of f of x. Direct substitution. F of x is 1 over x, so I'm just doing a direct substitution here. Put 1 over x because that is f of x. And now I'm going to plug into my g function, instead of where there's an x, I'm going to plug in 1 over x wherever there's an x. And remember, my g function is 2 times x. So instead of that, I'm plugging in 1 over x. So that's 2 over x. The domain is the same, all real numbers except 0. Interval notation, negative infinity to 0, union 0 to positive infinity. Next one. I have another functions for f of x and g of x. F of x is x plus 3, g of x is 2 over x. Direct substitution here. F of, instead of g of x, I have 2 over x. And for the f function, instead of f of x, I have, instead of x plus 3, I have 2 over x, because I'm plugging that in for my x plus 3. So it's 2 over x plus 3. Domain, again, all real numbers except 0. Negative infinity to 0, union 0 to infinity. And g of f of x is g, f of x is x plus 3. My g function is 2 over x. But I don't have x, g of x, I have x plus 3. Now, a different domain. The domain, all real numbers except negative 3. So negative infinity to negative 3, union negative 3 to positive infinity. And if you have trouble getting the interval notation, here's the easiest way to do it. I would think that you could graph all real numbers except negative 3. That's what it looks like. Now look at this from left to right. It goes from negative infinity, a break at negative 3, starts again at negative 3, to positive infinity. So that's how you do negative infinity, negative 3, union, negative 3 to positive infinity. Let's find f of g of h of 3 for f of x is equal to 4x, g of x is equal to 3x plus 2, and h of x is equal to x squared. So I have h of 3. H of 3 is 3 squared. So there's 3 squared, which is 9. G of 9, innermost. G of 9 is 3 times 9 plus 2. 3 times 9 is 27, plus 2 is 29. And now I have f of 29. F of 29 is equal to 4 times 29, which is 116. Innermost parenthesis, work out. F of negative 1, 4 times a negative 1. So I have h of g of negative 4. Now in my g function, I'm going to plug in negative 4. 3 times a negative 4 is negative 12, plus 2 is negative 10. In my h function, I'm going to plug in a negative 10. Negative 10 squared is 100. H of 2. Well, h of 2 is 4. So then I have h of 4. Now I'm going to plug 4 into my h function. So I have 4 squared, which is 16. So I have h of 16. Plug 16 into my h function, and I have 16 squared, which is 256. Last one. No numbers, just the functions. F of x is 4x. So plug in, do a substitution. Instead of f of x, put 4x here. Now into my g function. Instead of g, or x in the g function, plug in 4x. So I'm going to do 3 times 4x plus 2. 3 times 4x plus 2 is 12x plus 2. Now in my h function, instead of h of x equals x squared, I have 12x plus 2 is what goes in for my x. So I have 12 plus 2 quantity squared. And you don't need to FOIL this. You just leave it right there. If I had this on a test, I'd probably just have you stop there. Next one. Let f of x equal x cubed, g of x equals the square root of x, h of x is equal to x minus 4, and j of x is equal to 2x. Express each function k as a composite of the three of these four functions. So I'm going to use the functions. So I have a square root here. That's my g function, right? This right here is a g function. I have a cubed here. And the cubed is the f function. I have an x minus 4. That's your h function, okay? The j function I'm not using here. So order of operations, if you were going to multiply this out, if there were numbers in there, the first thing you would do is your h of x, the x minus 4. So that's the very first thing that you would do. So I am just going to put h of x in there instead of the x minus 4. Now, the next thing you would do is cube it. And the cube function was the f of x. So the f function goes in front of that. And then the very last thing you would do is take the cube root, or square root of that, which is your g function. So then g goes in front of that. So there is my composite function. Just like order of operations, you work from the inside out. You do in the parentheses first. So, and in this case, actually, it really would not have mattered if you would have done the square root, the cube. Okay. You could have done the cube because square root's to the half power. So you could have done a half power and then cubed it too. So, the homework for all this too will not be on here. It will be online. So make sure you do look online for the 2-8 homework. So let's do a few more problems. First thing. So if I was going to do that, I would replace x cubed with the f of x. Okay? Okay. I have the minus 4 next. So that's the h of x. So then an h goes in front of the f of x, and then I don't have the minus 4. Square root's the last thing, g. So g goes in front of that. Oops. Okay. This is how you do this one. This, there's no other order to do it. It has to be done this way. Because if you were doing this mathematically, you would cube this number first, then you would subtract the 4, and then you would take the square root. So you would cube the 4 first, so that's your cube root, subtract 4, that's your h function, and then you take the square root, which is your g function. So look online and for the homework for section 2-8.